Alright, so today we're going to learn how to name the next class of organic compounds. And for the next group, we'll look at alcohols. Okay, so alcohols, how we recognize them is there is what we call a hydroxyl group. Okay, so very similar to the polyatomic hydroxide bonded to a carbon. Okay, so I just show this to mean that this group right here is bonded to a carbon somewhere on the molecule. So let's go ahead and look at an example. Okay, so now hopefully you see what I meant by that. You can actually show the bond between the oxygen and the hydrogen, but it's pretty standard just to write those side by side and assume the bond's there. So for alcohols, let's underline the OL in alcohol. So like we always have, we want to start off by counting the number of carbons. So 1, 2, 3. Okay. So the base we'll use is propyl. So we'll drop off the YL and just put PROP. So this is where the naming is a little bit different. So we still have to include either the AN, the EN, or the YN ending, either the AN for only carbons and hydrogens with single bonds, EN for double bonds, YN for triple bonds. Okay, so there are only single bonds present here. So propan. Then we put the ending OL to tell me it's an alcohol. So now, as always, you have to tell me where the OH group is, so where the functional group is. So a functional group is just a group of atoms that aren't simply carbons and hydrogens bonded together with single bonds. So no matter which way we number it, okay, it gives us the same number for the carbon the OH is bonded to. So we have 2 propanol. Okay? So just so we're on the same page, this right here is not a carbon. That is just showing where this carbon is bonded to that oxygen there, so don't be confused by that. So let's go ahead and look at another one. Actually, let's go ahead and let's look back at this name, make sure we're on the same page. So the prop part of the name tells me there are 3 carbons. The AN tells me only single bonds. The OL tells me it's an alcohol. And the number 2 tells me where the OH is. Okay. So every part of that name tells me something slightly different about that molecule. So let's look at another one. So first step, we identify it as an alcohol. It has this OH, so we know we're going to name it as an alcohol. Then we count the number of carbons, 1, 2, 3, 4, 5. It's going to be pent. We have only single bonds, so AN, and it's an alcohol, so we have OL, so it's pentanol. So we can number it 1, 2, 3, 4, 5, or we can number it 1, 2, 3, 4, 5. So we number it the second way, okay, and give the OH, the carbon with OH on it the lowest number possible. So the 2 tells me where the hydroxide group is, okay, so it tells me where the OH is. So if I had numbered this incorrectly and I put 4-pentanol, 4-pentanol would still correspond to this structure. It's just not a proper name. It would be an invalid name for it. So let's look at one more like this. So it's alcohol. We recognize that. So we count the number of carbons, 1, 2. So the prefix that corresponds to 2 is eth. Okay. So there are only single bonds, so we put AN, it's an alcohol, so we put OL. I don't need a number here. There's only 2 carbons, so whether I put it on the first carbon or the second carbon, the molecule would be the same. So let's just imagine drawing it like this. Okay, those are the same molecule, so either way, same thing there. Ethanol is the alcohol that is used for human consumption. So I know we hear the term alcohol a lot, and you correspond that to this particular chemical compound if it's being used for consumption. So all these other alcohols would be toxic, okay, so be sure you make that differentiation in your mind there. So let's go ahead and go from the names to the formulas now. So let's look at 3-hexanol. So let's go ahead and kind of dissect this name. So hex would be the easiest thing to look at first. Hex means 6 carbons. 1, 2, 3, 4, 5, 6. So that's the first part. AN tells me only single bonds, so I'm good. OL tells me there's an OH somewhere on here. The 3 tells me where. It doesn't matter which side you start on when you're drawing it yourself. You could do 1, 2, 3 and put an OH, or you could do this 1, 2, 3 and put the OH there. Okay? I know this might look a little different to you, but those are the exact same molecule here. So for this case, both of these answers are identical, so either way would be perfectly acceptable. So let's look at one more. Let's draw the structure for 1-octanol. Okay, so the easiest part is to draw the 8-carbon chain first. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Then to put a hydroxide group on the first carbon. The AN again told me only single bonds. The OL told me an alcohol group. The 1 told me where to put it. Okay. So it's a good habit to go ahead and go back and count the carbons when you're done. 1, 2, 3, 4, 5, 6, 7, 8. It's easy to mess up and do this. 1, 2, 3, 4, 5, 6, 7, 8. To start off with 8 carbons and then put an OH on it without adding an extra bond there. So be careful for that. If you made that mistake, you could go back and double check yourself. 1, 2, 3, 4, 5, 6, 7, and you realize you've messed up. Okay. So it's a good habit to go back every time and double check and recount and make sure you have the proper number of carbons in your molecule.